Hello everybody, so today I will be explaining to you on chapter 6, which is on rotation of rigid body. So this chapter would be your assignment chapter, and there are 4 subtopics. Usually they will give you one subtopic, one question na dalam the assignment. Usually, I don't know. So the first one is on rotational kinematics. You have to be able to define and use all of this here. Analyze parameters in rotational motion with their corresponding quantities in linear motion, and lastly, solve problems related to rotational motion with constant angular acceleration. Okay, so let's look at the terms used to describe rotational motion. Firstly, we have angular displacement. So in linear motion, this is your S ka? Macam S. Yeah, S. And then, so for this chapter, the definition is the angle undergoes from a fixed reference line lah. So this is your reference line. For example, we always put our x-axis as our reference line kan bila kita mau when we want to talk about the angle. So this is your reference line. So the formula is theta equal to S over R, where theta is the angular displacement, S is the arc length, R is the distance from the rotation axis. Okay, so this is the arc length S lah. So the unit is, SI unit is radian, but it can also be revolution ataupun degree. You just have to remember that you need to convert it into the SI unit dulu, baru you can solve it lah. For example, maksud saya, R needs to be in the SI unit, S pun needs to be in the SI unit, begitu. So for sign convention, and anti-clockwise punya motion would be positive, clockwise yang akan jadi negative. Okay, so anything that is going like this is positive, anything that going like this is negative. Okay, so that is just the unit conversion. Next, we have angular velocity, where this is omega. Okay, some students cakap this is W. No, this is not W, this is omega. This is the Greek letter omega. So we have average and then instantaneous. For average, this is the rate of change of angular displacement. Rate of change of angular displacement. The formula is given here, and it has the SI unit of radian per second. It can also be RPM ataupun RPS. Remember, this is a vector quantity, so it has direction. The direction can be determined by using the right hand grip rule. Okay, so our fingers curl in the direction of rotation, and then the thumb is pointing the direction of angular velocity. Next, for the instantaneous pula, it is the angular velocity at a specified position ataupun at a particular of time lah. So the formula is this one. Next, we have the angular acceleration. So this is the Greek letter alpha. So we have average and instantaneous. So average pula, maksud dia, the definition is the rate of change of angular velocity. Okay, so it is a vector quantity with the SI unit of radian per second square. So if the alpha is positive, maksudnya omega is increasing with time. Maksudnya rotation is speeding up. If it is negative, omega is decreasing with time, so the rotation is slowing down. We have instantaneous angular acceleration as well. It is the angular acceleration at a specified position ataupun at a particular of time. Okay, so that is the terms used to describe rotational motion. Actually, the corresponding linear quantities di sini adalah angular adalah. It's just velocity v, but this is angular. Acceleration is just a. Okay, macam tu. So this is the rotational motion with uniform ataupun with constant angular acceleration. So this one should be, actually this should be A. So we have linear and rotational motion, both can have constant acceleration. Okay, so this is the corresponding quantities lah. And this is the relationship between angular and linear quantities. Okay, so basically that is just the theory part for subtopic 6.1. Example number 1, the angular displacement of the wheel is given by this equation here. So theta is in radians and t is in seconds. The diameter of the wheel is 0.56 meter. So we have to we have to determine the angle in degree at this period of time, the distance that the particle in the rim moves during this time interval as well, and C, the average angular velocity between this period of time, and lastly the instantaneous angular velocity at time equal to 3 seconds. Okay, so for question A, we will just be substituting that value of t into this equation given here lah. So first we have t 2.2 seconds, so that is just theta 1 equal to 5 2.2 minus 2.2. So this would give you 22 radian. And since the question asks you to find it in degree, you just have to times it with 180 divided by pi, which is 1261 degree. Next, for t equal to 4.8 seconds pula. So that is equal to 4.8 square minus 4.8. So this one, it will give you 110 radian. Multiply it with 180 divided by pi, which give you 6303 degree. Okay, so that is the angle in degree for that time period lah. Next, we have to calculate the distance that a particle on the rim moves during that time interval. So for this time interval, we have to find the arc length. So for that one, we will be using delta t. So this is this is 0.56 divided by 2. This is what is this? We have to use, for this one we have to use radian lah, sebab it is in the SI unit, minus 22. So the arc length, the distance that the particle is moving within that period of time, is equal to 24.6 meter. Okay. Question C pula, we have to calculate the average angular velocity in radian per second and in revolution per minute between that time interval. So this one is just omega equal to delta theta over delta t. So this is 110 minus 22 divided by 4.8 minus 2.2. So the average angular velocity is equal to 33.9 radian per second. Okay, so for this one, let us convert into revolution per minute. So how do we convert it? We will be, this is radian, this is 1 second, so we have to times it with radian. 1 radian is equal to bukan 1 radian, 1 revolution divided by 2 pi radian times with 60 seconds over 1 minute here lah. Okay, so itu adalah cara kita convert from radian per second to revolution per minute. So you will get 324 revolution per minute, macam tu lah. Okay. Next, question D, we have to calculate the instantaneous angular velocity, that is just omega d theta over dt. So the d theta is your, so your theta here is the equation that is given in the question. So that is, derive this in terms of t, you will get 10, 2 minus 1, so t minus 1. Okay, so dari sini kita dapat an equation where we can substitute 3 second, t equal to 3 seconds. Okay, so omega equal to 10, 3 minus 1, dapatlah 29 radian per second as your answer. Okay, so this is the solution for example number 1.